Recording, okay. Be so too bad if I forgot in the last week of classes. Exciting times. Tempting to not even come to class, I guess.
What are we doing on Thursday?
On Thursday, I just want to do kind of there isn't enough time to go through the entire course, so I call it a final exam overview. But if there are problems that you want to kind of work on, we can do that. Yeah, just kind of like expect this many marks and like these types of questions from test one and test
kind
two.
of like what you did for the second midterm, where you went over basically
Yeah.
everything.
Yeah, so just kind of an overview. But then if there are questions that you want to work through, I'll tell you if it's worth working on. And then if it's worth working on, we can work through it, if that makes sense.
Are you gonna upload like a final exam practice or?
Yeah, I just need to tweak a little bit at the end because this is new to me, or like this worksheet, and so I'll post it later today. Yeah, but it'll be the same, like a mom practice. Yeah, so you'll have a practice for the final exam. Yeah, nice. So that's the plan. But and then you're done. Wow. Busy time. I know. So I cobbled together this worksheet. It's kind of a because we don't have time to do an entire new chapter, and so then I just kind of pulled what we need and nothing that we don't, and so if it feels disconnected, then that's why. But hopefully we can just kind of get what we need out of it, and nothing that we don't. I am trying to avoid radians. That doesn't mean that I'm kind of shying away from the pies, right? Pi over 2's, 3 pi over 2's, but your answers will be in degrees, okay? And so, because the pies will cancel, and the pies are the clues that you're in radians. So, you've all got a copy? Just a little bit of review here, and I posted a PDF on Moodle if you prefer PDF. A little bit of review. If you have a circle with a radius r at an angle of theta, then the coordinates x, y. Oh, there's a worksheet here. Nice. We're going to work through. Then x is at r cos theta and y is at r sine theta. And so, of course, if you have the unit circle with a radius of 1, then you can replace r with 1s, and then you get x is cos theta and y is sine theta. Wanted to bring that up because we'll be relying on that to solve some problems today. As another side note, if you have radians and you want degrees, what you'll do is you'll multiply by 180 degrees divided by pi. And what's going to happen is from the radians, you'll have some pi and it'll cancel. And vice versa. Usually we don't work in this direction, right? If you have degrees and you want radians, then you can multiply by pi over 180. And why do we have this symmetry? We have a circle. Then the distance around here is 2 pi or 360 degrees, right? Which means that 2 pi is equal to 360, which means that if you want to move between them, 360 over 2 or 2 over 360, Right? Another thing that I realized when I did my run through that we will rely on is that sine squared theta plus cos squared theta is equal to 1. I'll say recall. We introduced that last day, and so I'll kind of lump it in with the review. This doesn't look like sine. Sine squared theta. And sine squared theta is the same as sine theta squared. It's just a nicer way of writing it, or a more common way of writing it, I should say. You might have seen, I can't remember which assignment it was that I posted, and I thought, I think they know the cast. Cast, does that kind of ring a bell? But I posted an image of cast, and what it is if you have your unit circle, I've given you lots that we'll pick apart here in just a sec, but for now, right, this is your first quadrant, quadrant 1, quadrant 2, because remember, this is your initial side, and so what you're doing is you're working around the circle. Okay, and so this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So when we talk about quadrants, that's what we mean. I do kind of assume that you already know that, though, but there it is. Okay. Now, for better or for worse, I'll give you this massive unit circle on the final exam, right? And so you'll have all this information. Usually, of course, if we have more time in the course, and I know in the States, it's funny, Trig is its own course, and so they don't just sneak it in at the very end like we do. And so there's a lot of material here. And of course, if we had more time to work on it, we would kind of develop these ideas. But here I just, bam, give them to you. And so we introduced this idea of, okay, well, I can turn angles and points on a circle into triangles, right? And so we call those special triangles, and there are some kind of natural stopping points that we have. And so notice that these are kind of the special triangles are being replicated, but not in the same order as you move around the circle. And so you could get there, right, if you kind of work through your first point here. If you're at x is root 3 over 2 and y is 1 over 2, what does that mean? If you map that back, to here, right? This is the unit circle, which means the radius is 1, so it's even simpler, right? Then it means that x is equal to cos theta, and x in this case is root 3 over 2. What you would find is that that's at pi over 6. Now, this is in radians, but you could, if you wanted to. There's usually no benefit in converting it to degrees, but if you prefer to look at degrees, that's fine, right? You could multiply by 180 over pi, right? And you could find pi over 6 times 180 over pi is basically 180 over 6, which puts you at 30 degrees for this first one if you want to convert them, right? And then you'll move all the way around. So for these xy coordinates, right, if x is kind of corresponding to the cosine and y is corresponding to the sine, right, sine of 1/2, then you know that you should get the same angle regardless. So there's a lot going on here, but the cast rule that I was mentioning starts down here for some reason. And then moves around. So cast this way. What it tells you is that all, so sine, cosine, and tan are all positive here in the first quadrant. And that's because the cosine is positive, right? All your x's are positive here on the positive x-axis, and all your y's are positive on the upper quadrant. Right? S is because the sine is positive, which means the cosine is negative, which means that the tan is negative. We haven't talked about tan, but we will later. In the third quadrant, tan is positive, but that means that both your cosine and your sine are negative. And then in the fourth quadrant, cosine is positive, which means that your sine will be negative. Right? So it's just a way of picking out different solutions, depending on what quadrant you're in. Nice. So there's a lot of information on there. We're going to pretty much just focus on the angle, and the questions that I've chosen will work nicely with the radians, the pi over 6, pi over 4, pi over 3, because they'll cancel out. Okay? And so that's why I'm not converting all of these to degrees, even though you could if you wanted to. Right? And we'll talk about x and y coordinates on this unit circle. And a lot of the time it'll be helpful if you're able to map back to some known coordinate on your unit circle, right? Because then you can figure out what angle it is. If you've worked with, well, if you've done any trig in the past, you've probably seen the graphs for sine and for cosine, right? They're these kind of wavy things, right? And the reason for that is if you've got your circle here, then we start, the point starts here on the initial side, and then what we're doing is we're mapping out what happens as you move up the circle. And so the angle is on the x-axis, right? That's your theta. And then the output is the sine of theta, right? The sine of theta is the y coordinate. And so what happens is you're moving through and your y is increasing until you reach a highest point of 1. And then it starts going down. And then all of a sudden it crosses, not all of a sudden, but steadily it crosses the x-axis, right? And then you're below the x-axis here. And then you get back up to your starting point. And then it just keeps cycling through like that forever, right? If you think about a wheel, right? Common example is a Ferris wheel. right? Because then you can imagine yourself sitting on the Ferris wheel going around, right? And so the general graph for sine, right, is going to be, it's going to start here at 0. Why is that? Because sine corresponds to the y coordinate, right? From up here, whoops, y is sine theta. Yeah? And so sine starts at 0, y equals 0. And then it keeps going up, and then it goes down. Cosine looks similar, but it's going to start at 1. Why? Because if you're looking at the x coordinate here, right, then it starts at x equals 1, and then it's going to decrease, right? It's moving further and further in as you get to the top of the circle where it's at x equals 0, right? And so it's going to get smaller and smaller and smaller. How I remember it, if I have to remember it, is the cosine starts high, right? And that's because in alphabetical order, if you're stacking them, then C comes before S, right? And so if we kind of did our sine graph, f of theta equals sine theta. Let's see if I can do it properly. It's going to peak here at pi over 2, and then it's going to cross at pi, and then at 3 pi over, oops, don't do that, Emily. 3 pi over 2, it's got a valley, and it's going to cross here. So so if you think about them in alphabetical order, right, cos would be higher than sine, if you have to kind of remember that. We won't, but in general. And then, of course, it keeps going. Either way, you get these kind of up-down motions, and they keep going, and they stretch in either direction, right? And so, of course, it keeps going in that direction as well. And they just keep going and going and going. Now, what do we know about functions? The vertical line test. Well, if I do the vertical line test here, then these are functions, right? Throw back to test 1, right? Is it 1-to-1? Are either of these 1-to-1? They're not, right? And so what do we do? If we have a function, but it's not 1-to-1, then, and we've already worked with the inverse, right, of the sine and cosine, and so we know that they exist, but what do we need to do? We need to restrict the domain until it's 1-to-1. So what we do is sine, if we restrict it to be between negative pi over 2 to pi over 2, then it's 1-to-1. Then I can check and I can see, okay, then it looks like, well, those weren't really horizontal, were they? Ding, 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 ding. Horizontal line test, which means now it's 1-to-1, which means we can find an inverse on this restricted domain. Whereas cosine, we limit it to be between 0 and pi, right? And so x equals 0 to pi. And then it would just kind of not be 1-to-1 anymore. Tangent, just for completeness, we limit to negative pi over 2 and pi over 2, not including those endpoints, but we're not going to work with the tangent so much. or at all. So now that we've restricted the domain, then we can find the inverse function. And a couple of notes on just kind of terminology. Sine, so the inverse sine, right? Sine to the -1, which is not 1 over sine, right? It's going to be the inverse. Okay, it's sometimes called the arc sine, and it's a little bit quicker to type, which is often why we use it, right? Arc sine of alpha. I remember we use Greek letters. It's kind of a bad looking alpha, in my opinion. Oh, because it's not, because it's the inverse. So it is just a number, A, not alpha. Phew. It'd be a bad looking alpha. We take the inverse of a number, right? Not an angle. And so same thing with the inverse cos, right, is called the arc cosine. And then the arctangent is the inverse tangent. So just so we can see what the inverse of sine looks like, right? What's been done, a reflection around the y equals x axis, and it ends up looking like this. Notice that the output is an angle, right? And so if you take the inverse of a number, then the output is going to be an angle. As a summary, and I'll put this on your formula sheet. And the unit circle, right, with triangles. Oh, I'll bring the official trig formula sheet next day. I'm just realizing, I don't know why, but it wasn't on the formula sheet before. I don't know where it went. It has existed. I don't know. I'll find it. Okay, so, oh, and I guess I don't think I even need to do review on SOHCAHTOA because I feel like you guys have it under control, but right, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Depending on what legs of the triangle you have, right, then you'll be able to find the angle, right? So from theta here, if we want to solve the triangle for the angle theta, and of course you could find the length of the missing side, and if you have this theta, you could find this missing angle, and then you would have all the components. But for now, let's just talk about what theta is. And we're going to leave answers in degrees, which means you can just work in degree mode. This from theta is the adjacent, and 12 from theta is the hypotenuse, which means that you have adjacent and hypotenuse, of course, which means you could use the cosine. So the cosine of theta is the adjacent, which is 9, over the hypotenuse, which is 12. From last day, right, we said, okay, well, if I want to solve for the angle, right, theta, then what can I do? I can just take the inverse cosine on each side. And then I'm left with theta is the inverse cos of 9 over 12. Now, you can use your calculator. I did add a note that I want it in degrees. So inverse cosine of 9 over 12 is roughly 41.40962211 degrees. If you're working in degrees, you have to have the degree symbol on there. Okay. Nice. A lot of information on the front page that we'll be referring to for the next couple of pages, right? And so now I feel like we're on easy street. But any questions about the first page? No. Okay. Then what I want you to do is you can work in groups. I encourage it, right? But try to solve the next two problems. Give you some time, and then we'll work through them. I'll pause the recording because that would be so boring. Resume. All right, let's see here. So I did say without using your calculator. How rude. Where you want to start is, of course, on the inside, which, yeah, of course. So if I could replace the inside of sine, well, sine takes an input of an angle, right? And then, so I can replace it with just a generic theta. But what that means then is that theta must be the inverse cosine of 4 over 5. Which, if I reverse engineer this, right, then the cosine of theta must be 4 over 5, right? Which all of a sudden, like, oh, I can probably draw that. I can figure that out, right? And so now, right, you have the cosine of theta equals 4 over 5. Now, from here, how I would solve it, because I want to find what essentially the sine of theta is, right? I've replaced this lob with theta, right? And so really what I want to find is I want to find the sine of theta. And I know what the cos of theta is, and there's an identity that I know that has both of them. And so from here, we can use sine squared theta plus cos squared theta is equal to 1. Oh. Okay. Cos squared theta is just cos theta squared. And so from here, I have sine squared theta plus 4 over 5 squared is equal to 1. Four squared is 16, 5 squared is 25, and so I can subtract 16 over 25 on the right-hand side, and then I'm left with sine squared theta is 1 minus 16 over 25. You can use your calculator, right? 1 minus, just use brackets, 1 minus bracket 16 over 25, and it will give you 9 over 25, or 0.36 if you prefer. That's fine too. Um, yeah, sine squared theta is 9 over 25. Here's the pickle. When I solve for sine theta, right, I take the square root. And when we take the square root, we have to remember the plus and the minus version, right? And so sine theta is the plus minus root of 9 over 25, which means that we need to pick which one, because I did say there's only one exact solution. Huh? Now, where that's going to stem from is that theta, because theta is the inverse cosine, cosine, the inverse cosine, where is it? Is restricted to be between 0 and pi. Right? And so that's the pickle. And so here, theta is restricted to 0 pi if you're working just with radians, or if you prefer between 0 degrees and 180 degrees. And if you're feeling kind of unsure about the 0 to pi, that's totally fine, right? You've got your circle, so between 0 and pi, right? That's where we'll be able to take the inverse cosine, right? And so, of course, that's 0 and 180 degrees. So, what does that mean for sine? Well, if we draw our circle, bink, bink, what we decided is that I can take the inverse of cosine in that highlighted area. Right? That's where I'll be able to take the inverse cosine, which means that theta is somewhere here in the upper circle, or the upper half. Now, if sine is your y value, right, then here I'm on the positive y-axis, positive y-axis, positive y-axis. And so all these outputs for sine are positive, right? And that's how you choose that you want the positive value. And so here, all sine theta values are positive, and which takes me back down here. Therefore, sine theta, but theta is actually a placeholder for the inverse cosine of 4 over 5. So I'm going to write out the whole thing. Sine of the inverse cos of 4 over 5 is positive. Root 9 is 3 and root 25 is 5. And so you can rewrite it as 3 over 5. I guess I'll add another line down here. Sine theta, just for completeness, is going to be the positive 3 over 5. Nice. No calculator required. That's nice. Okay. Did you guys have a chance to work on the second one? Want some time? Yeah, really sit with it. Okay. I'll pause this. Okay. Let's see here. All right. So, first thing I encourage you to do is, of course, kind of sketch out the problem. What is it that we're looking for? And so if we have a circle, that's a good place to start. And something like this. Ba, ba, ba. And the radius is 5 root 2. 5 root 2 is, for drawing purposes, kind of hard to wrap your head around. So 5 root 2 is roughly 7.07, which means that this point here is at 0, 7.07. And of course here I'm at negative 7.070, and so on. Just to give us kind of the lay of the land. And we want to find, so a circle with a radius of 5 root 2 intersects the line x equals negative 5. So somewhere here there's negative 5, and a line at x equals negative 5. Let's see if I can maybe make it look a little bit nicer. Would go like that. X equals negative 5. Find the angles, theta, on the interval between 0 and 2 pi, and not including 2 pi, where the circle and the line intersect. And so what that means is, okay, here's an intersection, and here's my second intersection. So really what we're looking for is, let's call this theta 1, and we can call this theta 2. Two different angles. Now my hint was, this is going to be a lot easier if we're able to map these points to a point on the unit circle. And so the way angles behave, right, in case it wasn't clear, so it doesn't matter what the radius is, right? If you're able to find an x and a y coordinate on the unit circle, it'll be the same. So if my first clue was, okay, if I have an x and I have a radius and I want to find an angle, then I need some way to combine those two. And so x is r cos theta. That's a good place to start. Because I'm going to force x to be negative 5. Right? And so I can force x to be negative 5 because at these points, which are the points that I'm interested in, right, then I need x to be negative 5 because that's the intersection. Or now I'm not going to use the rounded value because that's actually going to make it a lot harder. 5 root 2 cos theta. What you want to do is you want to isolate cos theta. How are you going to do that? You're going to do that by dividing both sides by 5 and then dividing by root 2, or just full on dividing by 5 root 2. And so you get negative 5 over 5 root 2 is equal to the cos of theta. 5 5 over 5 makes 1. So I get negative 1 over root 2 is equal to the cosine of theta. And I'll say here, look for this on the unit circle. That would be ideal. We have to do a little bit more work than that, but let's go there and see. And bring the whole, maybe just the part that we need. Oops. The cosine is going to be the x, right? And so x on the unit circle, oops, is cos theta. Okay, so if we know that cos theta is x, then, well, I have a negative x value, which restricts me to this side here, right? But also from my graph, I know that I'm going to have 1 up here and 1 down here. Right, so I will have a solution in both of these quadrants. Now, if I look at my x's, notice that these x's are the same, just in different order. So if I focus up here, my choices are negative 1 over 2. That's not what I want. I want negative 1 over root 2. This one looks promising, right? I feel like I could manipulate what I have to look like negative root 2 over 2. The root 3 is kind of bunging things up, so I'm going to focus on this negative root 2 over 2 and see if I can make that happen. Right. So here, let's turn this into, try to turn this into negative root 2 over 2. I can do that by multiplying by 1, right? Negative 1 over root 2 times root 2 over root 2. I'm not changing anything. Root 2 over root 2 is just going to be 1, right? I can multiply by 1 and it doesn't change anything. And so, but what you get is you get root 2 over root 2. That's getting me back. That's not what I wanted to do. You get negative root 2 over root 2 times root 2, which is 2. So just with that little trick, then we can turn negative 1 over root 2 into negative root 2 over 2, which I do know what it is, the angle. Right, and so negative root 2 over 2 is equal to the cosine of theta. And from the unit circle, right, now I'm focusing here. I know that one of the solutions that gives me that, or one theta that gives me that, is 3 pi over 4. The second solution that gives me an x of negative root 2 over 2 is 5 pi over 4. So now, from the unit circle, theta is 3 pi over 4 and 5 pi over 4. And if you wanted to, you could convert those to degrees, but I'm happy if you just leave it there, right? Find the angles. Theta is the angle. And so therefore, theta is 3 pi over 4 and 5 pi over 4. That's it. Without using your calculator. No calculator required. Probably. Let's see. You'll have your calculators. As long as you bring it. I'll bring my bag O calculators just in case. But there's only a few of them that are like your calculators. Yeah. Nice. Any questions about that one?
How do I get from 5 pi divided by 4 to
3? So if you have 5 pi over 4, that's going to be in radians. And so what you want to do is you want to multiply by 180 over pi. And so you could, I'll do it in a different color here. Or theta is 3 pi over 4 times 180 degrees over pi, which would cancel your pi's. And theta is 5 pi over 4 times 180 degrees over pi. Whatever that is. 3 times 180 divided by, I'll just do it. I was going to be all cool about it. 540 divided by 4 is 135. Nice. For completeness. But nice.
and either one would work as an answer?
Yeah. Mm-hmm.
You think they're gonna end up being nice like that?
I would make sure that they're nice.
Okay. So if I was able to just like,
I do feel like this is too hard for the final exam, but it's just to cover some bases.
like I can just tell like that it's 45.
Yeah. You could do that. Without your calculator, how would you show it? Anyways, how about this? So that is a method, and it's called using reference angles. And so it's a totally legitimate method that you have come upon. We just don't have time to introduce it. Yeah, then you could say, okay, yeah. Nice. But how about this? Well, unless you feel like you could do it on the final exam, but just as a straight question, I think it's maybe a little bit too tricky for a final exam question. It's more to tick some boxes. Did you do this? Did you do this? Yeah, I talked about it. And now we've talked about it. This graphs of sine and cosine is going to be kind of useful for solving the next problem, which I think is kind of a neat problem. And so if you have an equation, f of t is a sine bt plus k, or if you have the cosine version, then a is what we call the vertical stretch, and it's the amplitude of the function. So, you know, amplitude, right, then that's kind of the height. And so from a sine function, right, then we can shift it up and we can move it over if we need to, but for us, we're just going to keep it. And so we can shift the sine function up, and then we have the amplitude here, which is the distance from the midline to the peak, or the valley if you prefer. Now, B, right? B is inside the sine or the cosine, whichever you have. And it's going to be the horizontal stretch or compression. And it's related to the period, which is from one peak to the next peak. Remember, it's going to keep kind of just isolating, blah, 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 right? And so the distance from one peak to the next peak is called the period. Okay? And the period is 2 pi over b, right? Where b is from inside the sine or the cosine. And k, right, this little guy at the end here, is the vertical shift, just like we're used to, right? And so it's going to determine the midline of the function. And so kind of where it's hovering around. The starting point is, of course, at k equals 0, which means it would hover around y equals 0. Because I want to make sure you have time to try the next problem. Let's do this one together. We'll find the period of the function f of t is sine pi over 6t. Now you have the period is 2 pi over b. Okay. So let's start there. The period, which is of course p, is 2 pi over b. Now in this case, b is pi over 6. So replacing b with pi over 6, I get 2 pi divided by pi over 6. Now you're welcome to use your calculator here, right? That's fine. Those pi's will cancel. I'll do it with fractions, right? Because technically 2 pi over 6 is a fraction over a fraction, right? Which would look like 2 pi over 1 over pi over 6. But then to simplify, you flip the denominator and you multiply. And so then you get 6 over pi, which is how those pi's will cancel. And you get a period of 2 times 6, which is 12. Which means that for this graph, this distance from peak to peak would be a distance of 12. Slightly bigger function now. You have to find the midline, the amplitude, and the period of the function. Right? Then we'll map back to this generic. We had a sine function that we were given. So I'll paste that down here. Oops, huge. A is 3, B is 2, and K is 1. And so if you need to find the midline, going back to here, K is the vertical shift and determines the midline of the function. And so the midline is at, that's not what I wanted to do. The midline is at y equals k. So if you know k, then the midline is at y equals 1. Y equals k in general. The amplitude is the easiest because it is just the A. And so the amplitude is 3. And then we've already done some practice finding the period, but let's do it again. The period is going to be 2 pi divided by b. In our equation, b is 2, which is nice. And so p is 2 pi over 2. 2 over 2 is going to cancel, and you get a period of pi. From here, you can sketch this out. It doesn't ask us to, but let's do a quick sketch. I know it's a sine function, which means it's going to start at 0 and then move up. Right? And so that's a good place to start. And it's now starting at 0, it's starting at 1. And so let's do that. At y equals 1 is where it's going to start. I have a midline here. And in a distance of pi, I'll have gone from one peak to the next peak. Which means that at the halfway point, I should be kind of down at the very, very bottom trough, if you will. I'm not going to spend a ton of time on the period, but if this is pi, then the halfway mark would be at pi over 2. And from my amplitude, I'm going to go up 3 from 1. So here at 4, let's say, and if my bottom is at pi over 2, then my peak must be at the halfway mark, right? Pi over 4. I'm going to reach my peak here and down 3 from 1 to get to the bottom. Down 3 from 1 puts me at, say, -2 down here. And at pi, I did it weird, didn't I?
What, pi? It's on the bottom of it.
Yeah, it should be at, yeah, totally. Yeah. Thank you. Now I'm ready. Something. Sketch like that. Whoa. I feel like this one's off, but that's okay. I'm not going to make you sketch it. That was just for fun. Turns out it's not that fun. This next question I think is pretty neat. And so I'll give you some time to work on it, but a couple of hints, I guess, is I would encourage you to try to sketch it out. And don't worry about these, the x-axis, right? You can just kind of go with the general movement of the sine function. So don't worry about sketching out the period so much. It'll, besides the endpoint, right, getting out endpoint. So where I would start solving this problem is try to sketch it out and see what it is that you're looking for. And so the depth of a water at a dock rises and falls with the tide, which is, of course, cyclical. We understand that. And so following this equation, 4 sine pi over 12 t plus 7, I will encourage you to leave it as pi over 12 because it's going to be easier in the long run. Where t is measured in hours after midnight. Okay, so now we're talking about time. And a boat requires a depth of 9 feet, right? And so f of t is the height, right? Or sorry, the depth. I'll do this. The depth f of t. So it requires at least 9 feet to tie up at the dock. Between what times will the depth be? And I'll say at least 9 feet. Well, I'll let you try that one and see what happens. Pause this. All right. Confession time. I was staring at this. It just didn't look right. I fixed it. It would cross y equals 1 at pi over 2, of course, at the halfway mark. Sorry about that. Just needed a little bit of time. All right. So for this one, we're given an equation. Like I said, I think the best way to start any problem is to kind of sketch it out and map out what it is you want, even if you're not feeling 100%. And so from f of t equals 4 sine pi over 12t plus 7, I have an amplitude of 4. I have a b of pi over 12, which I'm going to use to find my period, p, which I have heard you got to the 24 hours, and so that's good. And then the midline is at y equals 7. It's the midline. And so from here, p is 2 pi over b. 2 pi over 12 is 24, which means 24 hours from midnight, which makes sense, right? If you're thinking about kind of tides and they repeat over 24 hours. Well, yeah, simplified version. Okay, so now what does this thing look like? Knowing that it's a sine function, whoops, where's my pointer? There. A sine function, right, means that it's going to start kind of at the midline. So what does this look like at 7? Let's put 7 there. Maybe I'll bump it up just a little bit. So at midnight, it'll be at 7 feet. And if we keep going over 24 hours, that's from the period, then I'll get back to my midline here. And if you wanted to, you could sketch it out at the halfway mark. It would cross again. With an amplitude of 4, that means it's going to reach a height of 7 plus 4, which puts me at 11. Let's use here. Something like that. Which means roughly at the halfway mark here it'll reach a peak of 11. And from, if an amplitude of 4 from 7, that means I'm going to drop down 4, which puts me at, let's put 3 kind of here. It's just to sketch it out the problem. So I have this kind of motion, although it got a little squished, but that's okay. Because what am I interested in? I'm interested in where the depth, let's put 9 here, is at least 9. Right? And visually, that's going to start here. Right? And it's true for this entire time frame between here and here. Right? And so we'll be able to find t's, right, starting here and then ending here. This 12 is only useful for checking my answers, right? I know it should be before noon. And so for my second time point, and I will point out that t is here on the x-axis, and the depth is f of t is on the y-axis. This is an intersection problem, right? F of t has to be at y equals 9, or f of t equals 9. And so if you rewrite your f of t as a y, right, then the midline is, or sorry, the point that, sorry, the line that we want is at 9, y equals 9. Wow, can't talk at all. So we want f of t is equal to 4 sine pi over 12t plus 7, and I want to force it to be 9. That's going to give me these intersections, and then because I've graphed it out, I know that it'll be between those two values that my solution is. Okay. If you didn't want to sketch it out, you could use a sign chart, right, like we did way back with inequalities. Okay, let's see what we've got here. 4 sine pi over 12t plus 7. So I want to kind of chip away at this thing and see what I can do, probably until I have just sine isolated, right? Sine of pi over 12t. And so I'm going to subtract 7 from both sides. And in the same move, I'm also going to divide by 4, right? 9 minus 7 makes 2. 2 divided by 4 must be sine pi over 12t. 2 over 4 is 1 over 2. And we'll use this sneaky maneuver again, where, okay, how about we just let pi over 12t be theta. So then we can say that 1/2 is sine theta. Sine theta from the unit circle, right? Sine theta is your y, right? And so sine theta is your y. And so you're looking for values on your unit circle that have a y of 1/2. Right? And so from this 2 over 4, you would try to morph it into a y value that you have on your circle. Let's see if I still have it. Nope. Don't know why I went there. I want to go maybe here. Copy. And so now I'm looking for y's that are positive 1 over 2 here. Right? So at pi over 6. And then if I make my way, y here. Positive 1/2. So at pi over 6 and at 5 pi over 6, and those are my only two options, which makes sense because I'm only expecting two options.
How did you get there from the pi divided by 12?
So what I did is I said, oh, okay, I'm just going to let this pi over 12t be theta because it is an angle. Because then I can say, okay, now once I know what theta is, right? Theta is going to be pi over 6 and 5 pi over 6. Then I can map it back and say pi over 12t must be pi over 6, and pi over 12t must be 5 pi over 6. I just haven't finished. Not yet.
Okay.
It's okay.
How did from the pi? How does the pi over 12 equal 1/2 on the?
Sine pi over 12t is equal to 1/2.
How are you saying that?
I'm saying that. Yeah. I'm just temporarily, because this is so messy to look at. I'm just.
You chose anything. You just decided to go with 1/2.
The 1/2 is from 9 minus 7 divided by 4. So that's where that 1/2 came from. And then I didn't want to look at this because that's a hot mess for now.
Oh, okay.
And then I'm saying, okay, well, I know sine theta is easy to look at. And if the y's is 1/2, then now I'll finish. Nice. Then theta is pi over 6 and 5 pi over 6. But now I wanted to find the time points t, which means that, okay, now I have to reverse engineer this and say, okay, well, theta is actually pi over 12t. And so now from here, I have pi over 12t is equal to pi over 6. And if you multiply by 12 and then divide by pi, you get a t of 2 a.m. And pi over 12t must be 5 pi over 6. Doing the same thing, I get 12 times 5, nice, is 60 pi, but then divided by pi, just not showing very much work. So then between 2 a.m. and 10 a.m. is when it'll be higher than 9 or higher, I should say. Nice. Time flies. Yeah.
Like I drew out, and I wrote out that it was from the.
Nice. I mean, I wouldn't be upset by that because what did you do? Then effectively you did plug in y equals 9 and you mapped it back to the x, which is what we are doing.
I guess I just made my graph.
It's the key. No, I'd be happy with that. Be happy with that. Me? Yes, but you would, because if you did, you just have to remember that there are 2 points, right? And so, because if you did the inverse sine of 1/2, right, then in degrees, it would give you 30 degrees, which is this first point here. Right? I personally think it's easier with the unit circle, but you could. Just remember that there are 2 solutions, which means that you'd have to figure out what this next one is as well.
So I originally had that as an answer of 2 a.m. to 10 a.m. But then I was like, since that was on the actual line of the circle, I thought I did that wrong. So then I just said, oh,
I mean, like here.
yeah, like so I made the circle.
Okay.
Then because I got the point on the circle at 2, I didn't actually I got 2 for 3.
Okay.
So then,
Oh, you found your x. That would work too. Totally. Just want to be careful with your pluses and minuses, I suspect. But if I had to guess.
but I took 2 third 3, and that was must have just the math. So yeah, that says it's like 63.4.
0.46. Have to have a look. How about a slightly easier one? I know.
Questions like this final, it would be more like the questions from 5.2.
Definitely more from the actual textbook. These are from the textbook, but like later on. I do want you guys to pick one of these word problems, and then we'll have a similar one. But you guys can canoodle and. An airplane needs to fly to an airfield located 300 miles east and 200 miles north of its current location. I don't know if you guys like the directional ones. Never eat shredded wheat. So if they're starting here and they have to fly, I think this one is a little bit more tame, kind of similar to 5.1. If they have to fly 300 miles east and 200 miles north of its current location, it's going to look like this. At what heading should the airplane fly? And so we're looking for this theta. And we've got 200 and we've got 300 for opposite and adjacent. And so from SOHCAHTOA, of course, you've got your tan theta must be 200 over 300. And we're ignoring air and wind and all those kinds of fun things. And so theta is going to be the inverse tangent of 200 over 300, which from earlier, I have roughly 33.69006753 degrees north of east. Nice. Now for the last page, because I know I'm out of time here, we'll do it for kind of tying up loose ends on Thursday, but I do want to clarify that you'll be given these values. Right, so given kind of this section here, and you should be able to prove this section, all these values. Now, for A, B, C, and D, I want you to use trig identities to write each expression in terms of a single trig identity or a constant. And then for the last one, just for practice, I want you to prove using only the given identities. So they are all on there. So the negative tan squared theta is equal to 1 minus the secant squared of theta, which is this one here. But you should be able to prove all of these. Now for the proof, just to give you kind of a leg up, what you want to do, or what I tend to do, is just focus on one of the sides. And for this last one, I would say focus on the right-hand side and try to morph it into the left-hand side. Because if you're manipulating both sides, then you might get lost, right? And so, or you could start manipulating on this side, but there's more to take from on the right-hand side. And so what's nice about proving identities is you know where you have to end up, right? You need to end up with negative tan squared theta on the right-hand side as well. And then these guys, you just want to use some substitutions. Now there are some like cosecant, secant, cotangent that we haven't seen, but they are given there. So just pick away at those and we'll start there on Thursday. Due on Thursday. You have any questions? We know. Otherwise, see you for our last class on Thursday. Crazy. No, I know.